So, Bismillah ar-Rahman ar-Rahim. Welcome everyone in our weekly session about basics of chemistry for IGCSE students. If you are Cambridge Assessment or Pearson Edexcel or Oxford EQA student in the future, so this session for you. Today, I'm going to talk about a very important topic is a very important for Cambridge Assessment and Pearson and Oxford EQA. What is this? This is electrolysis. This is what? Electrolysis. From the name, there is a link between electricity and chemistry. Electrolysis or electrochemistry. In this topic, there is a link between chemistry and electricity. By using electricity, we can break down the ionic compound. For example, if you have sodium chloride in NaCl, this is ionic or covalent? This is ionic. So electrolysis is only for ionic compound? Yes, exactly. Okay? So this is ionic compound. What is my goal today? What is my objective today? For you as a chemist, you need to separate sodium alone and chlorine alone. Okay? How? How you separate sodium alone and chlorine alone by sodium or by electrolysis of sodium chloride. Is it clear? But it is very important to remember electrolysis is only for molten compound or aqueous compound. What is the difference? We will know that. So I need to say there is no electrolysis for solid ionic compound. Never ever there is electrolysis for solid ionic compound. Table salt, which you have in your kitchen, in your home, if table salt is a solid, can you do electrolysis for solid sodium chloride? No, no. Sodium chloride must be molten or aqueous. Molten or aqueous. What is the meaning of molten? Anyone have any idea to share with us? Molten. What is the meaning of molten ionic compound? Anyone have any idea about molten? Yes, Malaka, write in the chat box, please. Or I can give you a chance to talk, by the way. Yes, open your mic.
Maybe molten means it's melted.
Yes. Molten, it means sodium chloride will be in a liquid state without water, without dissolving in water. So how? By heating. By what? By heating. So if you heat sodium chloride, table salt, I mean, by a high temperature, sodium chloride will be in a liquid state. Now, in a liquid state, we can start electrolysis for sodium chloride. In this video, we will watch together how we convert sodium chloride from solid state to liquid state without water, just by heating. Look here, I have two electrodes. The light, look here, you can see the bulb light up. After that, we will bring sodium chloride in solid state. This is solid sodium chloride, salt. This is table salt. If we add table salt here, there is no conduction for electricity. Look, the lamp doesn't light up. Why? Because here in a solid state, ions cannot move. Ions in a fixed position. But by heating, heat, more heating, look, there is no water. No water here, just heating. Look, Now it is in molten state. This is molten. For this state, in molten state, I can do electrolysis because now sodium and chlorine are free to move. Clear? So again, this is molten sodium chloride. Anyone have any idea how we can dissolve sodium chloride without heating? What should I do? What we can do? Hmm. How you dissolve sodium chloride to be in liquid state? I said one of this process by heating sodium chloride at high temperature. As you see, sodium chloride will change from solid to liquid state, and this is called molten sodium chloride. Yusuf Isam, do you have any idea? Another idea, I mean. تفضل. Yes, go ahead.
We can dissolve it in water.
Yes, exactly. So this is the second process. We can dissolve sodium chloride in water, and in this case, this is called aqueous sodium chloride, aqueous compound. Okay? So electrolysis can be for molten ionic compound like this one, or electrolysis of aqueous compound. I can do electrolysis for aqueous. Aqueous, aqua, you know aqua? The word aqua, it means water. So aqueous means something dissolved in water. Is it clear? What I will do by electrolysis. Number one, in Cambridge assessment, in Pearson Edexcel, in Oxford AQA, the first question is what is meant by electrolysis? In all boards, 2 marks for this definition. So what is the definition? What is meant by electrolysis? How many mark? Hmm? How many mark for this question? 2 marks. In Cambridge, yes. In Pearson Edexcel, yes. In Oxford AQA, yes. So what is the definition? Electrolysis is breaking down which compound, ionic or covalent? Hmm? What we said at the beginning of our session today, breaking down of what? Yes, breaking down of ionic compound. And this compound must be what? Hmm? Molten, as we saw together, heating until to be in a liquid state, or aqueous. Breaking down of ionic compound, molten or aqueous, by what? By what? By electricity. So I will use electricity to break down the ionic compound. What is the distribution of Mars? Breaking down of ionic compound, molten or aqueous, for this statement, it has 1 mark. It has how many mark? This one? Hmm? 1 mark. Okay? This is 1 mark. And imagine 1 mark for the word electricity. It is very important to understand, but it is most important to know what you have to write, isn't it? So 1 mark for breaking down ionic compound, molten or aqueous, and 1 mark for the word electricity. Clear for everyone? The definition is a very important, highly important definition in IGCSE chemistry. Clear? Definition is clear? 2 marks. By the way, before in 2017 exam paper, there was a question about that. Look, who carried the question? I prefer to share some questions from past exam questions. So this is exam questions, IG exam questions. So I am going to give a chance to Habib Abdelaziz. Yes, open your mic. Go ahead.
Yes, okay. Define a student sets up the following electrolysis experiment. Define the term electrolysis.
Yes,
Electrolysis is breaking down of an ionic compound, either molten or aqueous, by electricity.
yes. Habiba, how many marks for the question?
2 marks.
Can you give me distribution of marks?
Okay. For the statement breaking down of ionic compound, molten or aqueous, that is 1 mark, and by electricity, that's the second one.
Oh, yeah. So one word, it has 1 mark?
Yes.
Yes. This is IG system. Clear for everyone? For conduction of electricity in electrolysis, you can see here, what is this? This is called electrode. This is called what? Electrode. If you remember the video, this is the electrode. We call this is electrode. This is electrode. Electrode made up of what? Made up of wood? No. Made up of paper? No. How come? Doesn't make sense. So electrode, which you can see in the picture, made up of metal or non-metal. This electrode can be from metal or non-metal. If this electrode from metal, so this is from platinum. From platinum. Non-metal electrode is graphite. In some questions, he will ask, give me example of metal electrode. So what should I write? Metal electrode. Metal electrode. You must try it. Metal electrode is graphite. In some questions, he will say, give me example of non-metal electrode. What is non-metal electrode? Sorry, metal electrode is platinum. This is wrong. Metal electrode, this is platinum. Non-metal electrode is graphite. In some questions, he will say, write example of electrode. So, depends on your choice. Someone will write graphite, so it's okay. Someone will write platinum, it's okay. So again, electrode can be made from metal, and in this case, this metal is platinum, and electrode can be made from non-metal, and in this case, non-metal is graphite. Here, so put in your mind, platinum is a metal electrode. Platinum is a metal electrode. Graphite is a non-metal electrode. Okay? So it depends on the question. Some questions asking about the metal electrode, so you have to write platinum. Some question asking about non-metal electrode, so you have to write graphite. Some questions they didn't mention, just they asking about the electrode. Okay? Is it clear till now? So to summarize what I said, electrolysis is a breaking down ionic compound, molten or aqueous, by electricity. 2 mark. Next question about electrode. Electrode can be made from metal like platinum or non-metal like what? Like graphite. This is introduction about electrolysis, and this is very important. By the way, when you start to study electrolysis, divide in your mind as a mind map. Electrolysis, we divide electrolysis into introduction. This is what I said at the beginning of my period today. And number 2, electrolysis of molten compound. This is the second part. You have to make sure you know electrolysis of molten compound. And the third one is electrolysis of aqueous compound or aqueous solution. And the fourth part is application for electrolysis. Clear? So at the beginning, I talked about what? Remember, I talked about introduction. I talked about definition of electrolysis. I talked about what is the difference between molten and aqueous. And finally, metal electrode is a graphite, non-metal electrode is metal electrode is a platinum, non-metal electrode is a graphite. Okay? The most important question, why platinum and graphite? Why? Why? For 2 reasons. Why platinum? Because platinum is inert electrode. What is the meaning of inert? Inert doesn't participate in any chemical reaction. Okay, inert. 1 mark. Number 2, conductor of electricity. Maybe someone asking me, why Muhammad, why you cannot choose iron as electrode? Why platinum? Because platinum is inert electrode. Inert? What is meant by inert? Oh, inert. Doesn't participate in any chemical reaction during electrolysis. Number 2, this is good conductor of electricity. Okay? This is the first part of my session today, introduction. Now, electrolysis of what? I will talk today about electrolysis of molten compound, and I need a paper from everyone because you will do some of work. So now what we have? Electrolysis of molten ionic compound. Molten, what is the meaning of molten? Who can tell me? Molten, what is meant by molten? Molten, anyone have any idea? Have Malak, okay, Malak, open your mic, go ahead. Molten,
Mol-
what is meant by molten, ya Malak?
It's by being melted by heat, but not with water.
Again?
It's being melted by using heat, not water.
Yes. Molten, guys, it means I will convert the ionic compound into liquid state. For example, table salt in our home, I will convert sodium chloride, table salt, into liquid state, but without water. How? By heating. By heating. I will heat sodium chloride. To understand electrolysis of molten ionic compound, let's to take this example. Electrolysis of molten sodium chloride, which is NaCl. Okay, look with me here. This is the cell of electrolysis. This is the cell of electrolysis. Draw here the first electrode, here the second electrode. Connect this electrode with the negative sign of the battery. This is with the positive side of the battery. So here I have negative electrode, and here I have a positive electrode. How many electrodes? Two. One of them is negative, one of them is positive. The negative electrode known as cathode, cathode. And the positive electrode is known as anode. So again, what I will do now with you, electrolysis of molten sodium chloride. What is this? This is the cell of electrolysis. This is the negative electrode, which is made from platinum or graphite, as you like, okay? The negative electrode known as cathode, and is a positive electrode known as anode. The positive electrode known as anode. This is sodium chloride. So what are the ions I have? Listen to me. Sodium chloride. So what are the ions I have? Sodium chloride. So what are the ions? I have sodium ions and chloride ions. This is sodium, Na. Always the first one will be positive ion. Always the first one will be the positive ion. So Na is a positive? Yes, Na is a positive. So this is Na, which is a positive. Oh, Muhammad, do you mean Na is a positive, so Cl will be a negative? Yes, exactly. Cl is a negative. Do you have another ions? No, I don't have. I don't have. So only Na positive and Cl negative? Yes. Nothing else? Yes, because this is molten. Because this is molten. Okay? Okay, clear. In the exam paper, the examiner will ask you to write ionic half equation. It's called what? Ionic half equation. Ionic half equation at cathode and at anode. These are the questions. Write ionic half equation at cathode and at anode. Now, cathode, I said cathode is a negative. Look, cathode is a negative. So what do you think? Cathode will attract which ion? This is negative, so will attract the positive ion or the negative ion? What do you think? Write in the chat box, please. Cathode is a negative, so will attract the positive ions. Yes, exactly. So the positive ion will attract it to cathode. This positive ion attracted to cathode. Cathode is a negative. It means it's rich by electrons. So at cathode, there is Na positive plus. Always at cathode, write plus. Plus how many electrons? Look, here you have positive charge. So plus 1 electron. what will happen? Cancel this electron with this positive charge. So now you have Na at cathode. Here, Na will form. Sodium will form. Clear? So again, what I have here, I have a negative electrode, which is cathode, and a positive electrode, which is anode. What are the ions you have? Na is a positive, Cl is a negative. Always the first one is positive and the second one is negative. To write ionic half equation at cathode which is negative will attract the positive ion. So Na positive will gain how many electron? One electron. Why? Because it has a positive charge. Cancel one electron with a positive, so you have Na at cathode. Now I have sodium at cathode. Now I obtain sodium, isn't it? Okay? Yes, Habiba. Cathode will attract the positive and the anode will attract the negative. So anode. Anode is a positive ion. Look, anode is a positive. Will attract what? Will attract what? Anode will attract Cl minus. Anode will attract the chloride. This is called chloride because it has a charge. Chloride. If you have chloride, write 2Cl negative, lose, make arrow, and write Cl2 plus 2 electrons. So what are the products? The products are sodium at cathode and chlorine gas at anode. At the beginning, it was sodium chloride, table salt in our home, table salt. By electrolysis, we break down sodium chloride and we obtain sodium metal at cathode and chlorine gas at anode. So again, cathode is a negative, anode is a positive. Cathode will attract the positive ion like this. In a positive will gain one electron to form sodium. For anode, which is a positive, will attract Cl, but remember, always write 2Cl minus. 2Cl minus will give you Cl2, chlorine gas, plus 2 electrons. What are the final products of electrolysis? Sodium at cathode, chlorine at anode. That's it. Okay? Clear, guys? So are you ready for question similar to this idea? Binary compound, Habiba, you asking me about if you have more than 2 cation. In olefin, you have electrolysis of binary compound. Binary, it means you have positive ion and a negative ion. That's it. But in electrolysis of aqueous, we have another rule we have to follow. So again, yet for anode is a positive, will attract chloride ions. Always with chloride, write 2 to balance the equation. 2Cl minus will give me Cl2 plus 2 electrons. Are you ready for similar example to check your understanding? To check if you are understood my idea or not? Okay, I did electrolysis of NaCl. My question for you, follow the same rule, follow the same steps. I need electrolysis of molten KBr. The same idea I did in ACl. So in A positive, Cl negative, my question is KBr. So K will be positive and the Br will be negative, and they follow the same rules. Clear? Okay, take your time. So you have 2 minutes to finalize your work. After that, I'm going to solve the question with you. Okay? Okay. Let's start. Are you ready? So the same idea, by the way. Just I will read this because I don't need sodium chloride now. My question was about molten sodium bromide. It is very easy molten. You know why? Because only you have positive ion and the negative ion, nothing else. So again, I will start from the scratch again to understand. If you don't understand from the first explanation, you understand inshallah from the second one. I will draw my cell. So this is my cell. This is my cell. This is the negative electrode, which is known as, who remember, cathode. And this is the positive electrode, which is known as, who remember, known as what? Anode. This is the battery. Okay. What are the ions you have? What are the ions you have? KBr. Oh, K. You told me before the first one always is positive. So K is a positive. Exactly, yes. So K is a positive. Potassium ion. This is a cation. The second one is Br will be Br will be what? Will be negative. Exactly, yes. Write ionic half equation. Ionic half equation at cathode. So again, cathode is a negative. Is a negative electrode. Cathode is a negative electrode. So cathode will attract the positive ion. Oh, yes. So this one attracted to the negative electrode. At cathode, I have K positive. It will gain how many electron? It is only one positive. So it will gain one electron. After that, cancel electron with the positive charge. Now you have K. Only you have K. This is potassium at cathode. Potassium metal at cathode. Here, go to at anode now. Good evening, anode. How are you? Fine, Muhammad. I'm good, alhamdulillah. Are you positive or negative? No, 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 no. I am anode. I am positive. How come you are saying negative? Does it make sense? I am anode. I am positive. Okay, sorry. You are positive. So you will attract what? Oh, Muhammad, of course. I am a positive anode. So I will attract the negative ion. I will attract Br minus. Oh, so write Br minus. No, no, no. Write 2. Why? Why 2? To be balanced chemical equation. Oh, so the product is Br2 plus 2 electrons. Look here, at cathode, gaining of electrons, but at anode is losing electron. What are the final products I have? Potassium at cathode, bromine at anode. So by electrolysis, or what you did, you break down the ionic compound by electricity. You break down KBr into potassium and bromine. This is electrolysis of molten ionic compound. Are you ready for another example? Another example, and I will choose someone to participate with me. The example is molten lead bromide. But attention, please. This example in your syllabus, in Cambridge Assessment, in Pearson Edexcel, even in Oxford, they asked about molten lead bromide. This is BBBr2. Remember, ion of lead will be Pb positive 2. It has positive 2, not positive 1. It is exactly like NaCl, which I did. It is exactly like sodium, like potassium bromide, which you did. So you have 3 minutes to finalize electrolysis of lead bromide. Draw the cell, write the ionic equation at cathode and ionic equation at anode. Take your time, please. Take your chance to participate. Rimas, you raise your hand. You have any question? You can open your mic now, by the way.
Yes. What is like the two at the end?
This is
Like
Br2.
what's
Br2, it means you have 2 bromide ions. But in electrolysis, it will be the same. No change in electrolysis.
okay?
Okay? So it is
Yes.
exactly like in NaCl. But if you remember, in NaCl, I wrote Na positive. It has a positive charge. But here, for lead, it has positive 2, not positive like sodium.
Okay. Thank you.
Okay, welcome. So the new idea here, it's only for lead, because lead here, it has a positive 2, but what we did before, it was positive, only one positive. So Malak, yes, Malak, you raised your hand, I think, many times. So Malak Shinawi, you have a chance to open your mic now, Malak. Go ahead.
Yes. Can I answer?
Of course, yes. So first of all, before your answer, I need to draw the cell together to remember what we have. By the way, in the exam, no need to draw the cell. Just I'm drawing the cell for you. Malak, I have a negative electrode, which known as what?
Negative electrode is known as cathode.
Cathode, yes, exactly. And the positive electrode, which known as what?
Anode.
Yes, positive electrode, which known as anode. What are the ions you have here?
We have lead and bromide.
Yes, only you have Pb and Br, nothing else. What is the charge above lead?
Lead is positive.
No, I told you here, this one. Positive what?
Positive 2.
Yes, so lead is positive 2. And Br is a negative, as you know. No problem about Br. These are the ions you have. Do you have another ions? No, how come? This is molten. Molten, it means you have a positive ion and a negative ion. That's it. Now, I need ionic half equation at cathode or at cathode. Okay. At cathode, يا ملك, which ion attracted to cathode?
The BB, positive 2.
Yes. Yes, Pp, it has positive 2, so it will gain how many electrons?
2 electrons.
2 electrons. So cancel 2 electrons was positive 2. Now, what you have?
It gives you only PP.
Yes, so finally, I have a lead at cathode. I have a lead at cathode. Many factories all over the world, they use electrolysis, okay, to obtain lead from lead bromide. Okay, so at anode, what you have at anode, the same idea.
At anode, you have Br negative.
But how many Br I have to write here? 2
2.
Br. This is called bromide, because it has a negative charge. This is not bromine. This is bromide ions, yes? Then Malak,
And then it equals Br2 plus 2E negative.
say produce. Don't
Okay.
say equal. Say bromide ions, as a scientific word, bromide ions gives bromine plus 2 electrons. 2 electrons. What are the products I have? I have lead at cathode and I have bromine at anode. You can take a picture for this slide if you want that. This is electrolysis of molten lead bromide. Is a very, 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 very important example. Why? Because this example in your syllabus from the board, examiner said student must be able to write ionic half equations for electrolysis of molten lead bromide. Okay? Clear for everyone? This is electrolysis of what? Electrolysis of molten lead bromide. If you want to see just a video about electrolysis of molten lead bromide, which is a very, very important example because this is in your syllabus, whatever your board, you will find this. By the way, this electrolysis is not just for fun. No, No. Millions of dollars all over the world in electrolysis. Millions of dollars. Let's to watch the video together.
The Earth's crust contains many compounds. But the compounds themselves aren't as useful to us as the elements they're made up of. This rock contains aluminium oxide. Split the aluminium from the oxygen and you have one of the world's most useful metals. You can split a compound using electricity. The idea is to pass an electric current through it, a process known as electrolysis. A circuit is set up using 2 carbon electrodes, an ammeter, and a power supply. The white powder is lead bromide. Switch on the power supply, and nothing happens. The ammeter reads 0. Solid lead bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now, and a current flows. In this circuit, the electrode on the right is positive. The one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead. This is pure lead. So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine. To work out why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas. Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid? Change the compound from lead bromide to zinc chloride and the products of electrolysis will be different. What would you expect to see happening when electricity is passed through molten zinc chloride? This time, bubbles of a very pale gas appear at the positive electrode. It turns damp blue litmus paper red and bleaches it lighter. So what gas is it likely to be? Again, nothing appears to be happening at the negative electrode on the left. But pouring off the molten zinc chloride reveals a bead of pure zinc. In industry, electrolysis is carried out on a huge scale. Massive amounts of electricity are used to extract reactive metals, like aluminium, from their ore.
So now it's clear for, I think, for you, isn't it, about electrolysis? From here, we can imagine what happened. If you remember, we said what happened at cathode. This is lead bromide. What happened at cathode? Remember at cathode, what happened? What we said at cathode? We said Bb positive 2 will gain 2 electrons to form lead. If you see here, positive ions attracted to cathode here. Look, positive ions attract to cathode. All of positive ions now at cathode will gain 2 electrons to form lead metal. After gaining 2 electrons, will go down as a lead metal. Look here. Gain electrons, form lead metal. This one, lead. Go down, lead. Clear? Now, at anode, what we said, what will happen at anode? 2Br negative will form Br2 plus 2 electrons, bromine gas. It will lose electrons and it will form bubbles of bromine gas. Look. This is bromine gas will start to appear. So is it clear electrolysis of potent compound and electrolysis of aqueous solution? To finalize my basics of electrolysis today, I will summarize what I said. Electrolysis as a definition, how many marks? 2 marks. Remember, what is the definition of electrolysis? What is the definition, Habib Abdulaziz? Yes, open your mic, say.
Breaking down of ionic compound, molten or aqueous, by electricity.
Yes, exactly. Breaking down of ionic compound, molten or aqueous by electricity. Thank you, Habiba. Shukran.
Well,
After that, I talked about electrode. How many types of electrodes we have? How many types of electrode? We have 2 types of electrode. What are these 2 types? Metal electrode or non-metal electrode? So what is metal electrode? Metal electrode. Metal electrode is, yes, is platinum. You must write platinum. Platinum. And non-metal electrode is what? Huh? Graphite. This is graphite. After that, we talked about electrolysis of molten ionic compound. Molten, I mean, you will heat the ionic compound until be liquid without water. We talked about molten NaCl. After that, I will give you example about molten KBr. And finally, we watch together molten lead bromide. Finally, any question, what in your mind, any question about observation in electrolysis? Observation, write bubbles. If there is a question in electrolysis, the question says, write your observation. Observation means in chemistry, in IG, it means something you can see, something you can watch, you can hear, you can smell by your sense. Because some students say observation, oh, observation chlorine gas will form. No, no one can observe gas. You can observe the evidence of the gas, which is bubbles. Okay? So observation in any question in electrolysis. What is observation? Write bubbles. Because in any electrolysis, you will have a gas will form. Electrolysis of molten compound or aqueous solution. This is our basic of electrolysis today. Anyone have any question? Habiba, you raised your hand. You have any question, Habiba? Rimas, you have any question? Yes, Rimas, you can talk, yes. Rimas, I allow you to talk. I allow you to open your mic.
Yes. When my teacher was explaining this lesson, she said that it's not allowed to write breaking down. Instead, we should write decomposition.
No, the same, the same. Breaking down of ionic compound or decomposition of ionic compound, the same idea. Both are
Okay.
correct, okay?
Okay,
Because,
thank you.
so could you please explain for me the definition? Hmm. You can open your mic. I give you a chance. You close your mic, I think. So explain the definition for me, Rimas. Yes, Rimas, open your mic. What is meant by electrolysis? Explain the definition for me.
Yes, it's like you have an ionic compound and you want to break it down when it's in a molten or aqueous state. Like, no, you want to break it down to a molten or aqueous state by using electricity.
Yeah. Yes, okay.
Yeah. Yes.
So here you can write breaking down or you can write decomposition of ionic compound. Okay, if you are familiar with decomposition, it's okay, wonderful. Okay, guys. So you can say decomposition of ionic compound molten or aqueous, but you must refer to electricity because it has a one bar. Okay. Now, any question else? Abdurrahman, Mustafa, you raised your hand, I think. You have any question, Abdurrahman? No one have any question? Everything is clear? So even if you have any questions, feel free to contact me on our WhatsApp group. I will answer for everyone asking me any point. Uh, Homework will be provided about this lesson, even notes and recorded session. See you later. Assalamu alaikum wa rahmatullahi wa barakatuh.